Some crazy talk videos for A-level, AQA, Unit 5, Applied Physics. They all have a common steampunk theme, covering the Carnot cycle, the Otto cycle, the four-stroke versus diesel engine, and finally a comparison of the fuel cost of diesel to petrol engines. Video 1 asks two questions about the Carnot cycle. First, the specific heat capacity of engine coolant. Second, why car efficiency increases with running time.
Should coolant have high, or low, specific heat capacity? And here is another question. The Carnot efficiency says that the lower the cold sink temperature, the higher the efficiency. So, why is it that the efficiency of a car engine increases as it warms up, and reaches a constant efficiency after about 10 minutes of driving?
Video 2. Some double entendres about engines, followed by a question related to the Otto cycle four-stroke engine.
Hello steampunk engineers. I really enjoy repairing engines. I just love getting my hands on a big shaft, a crankshaft that is. I also like a stroke, a four-stroke. I repaired a four-stroke Otto cycle petrol engine just the other day. The four-stroke was hot, especially since combustion was occurring 1,000 times per minute in each piston. The radiator was cool. Well, with the extreme coolant in, it was very cool at 50 degrees C. The PV diagram indicated 75 joules of work for each cycle. Oh, talk about power. The engine had a 19.1 Newton-meter torque when working at 2,000 revolutions per minute. However, it seemed to burn fuel like it was going out of fashion, a bit like my headgear. It burnt 1.5 kilograms of petrol in just 1 hour. But is the engine inefficient?
Video 3. Comparing the relative merits of a diesel to a four-stroke engine.
Diesel and four-stroke petrol engines are internal combustion engines. Fuel is mixed with air as it goes into the engine, and that mixture is compressed internally inside the engine's cylinders. At some point, the fuel ignites, combusts, driving a piston down. Work is done by turning the crankshaft, which ultimately turns the wheels. Work is then done on the piston, moving it up in the cylinder, pushing the burnt gases out of the engine out of the exhaust pipe. The cycle repeats several times per second. The more cylinders an engine has, the smoother it tends to run, and the more power it can make, since the combustion events come very close together in time. However, the more cylinders an engine has, the more complex and mechanically inefficient the engine becomes. Diesel and petrol engines differ in how the fuel is ignited inside the engine. In a petrol engine, the air and fuel is compressed, and at a critical point in the timing of the cycle, a spark plug ignites the gas. But in a diesel engine, there are no spark plugs. When diesel fuel and air are compressed enough, the extreme compression generates enough heat that the mixture essentially spontaneously combusts. This is known as compression ignition, and it's the basis of how a diesel engine works. When a petrol engine suffers combustion ignition, we often call it knock, and it can ruin the engine. But diesel engines are built to take advantage of this. Both diesel and petrol engines make use of the Otto cycle. In a petrol engine, when fuel ignites, the pressure increases with constant volume, and thus heat energy is produced under an isometric process. Whereas with a diesel engine, the fuel ignites under constant pressure as the volume increases, and thus heat energy is produced under an isobaric process. For similar power output, diesel cars have more torque than petrol cars. Diesel cars have higher initial accelerations and can move heavier loads. Diesel engines' pistons complete one cycle with one turn of the crankshaft. However, petrol engine pistons complete one cycle with two turns of the crankshaft.
Video 4. Finally, a question comparing the cost of diesel to petrol. What about the cost of diesel compared to petrol? Diesel versions of the same petrol car are usually more expensive. Diesel per litre is usually slightly more expensive than petrol. The calorific value of diesel is 44.8 megajoules per kilogram, and that of petrol is 47.3 megajoules per kilogram. The density of diesel is 0.832 kg per litre and that of petrol is 0.745 kg per litre. But which gives the most energy per pound spent?